Welcome back to the engine history, everyone. Skilled mechanics have always wondered how machines built at the start of the last century could haul tens of tons through deep mud. Take a close look at the running gear of the 1917 Holt 120. This is a heavy artillery tractor built specifically for the mud-choked battlefields of World War I. In an era still driven by horses, the Holt 120 chassis used a tracked system to spread weight across soft ground and eliminate the sinking curse of rubber tires. Driven by an inline six-cylinder engine, this steel beast ignores speed and concentrates on torque at the very bottom of the rev range. Each intake, combustion, and exhaust into the crankshaft shows the brutally hard metallurgy of that era in plain sight. Shift to the North African theater, and we examine the M3 Grant, the British adaptation of the American M3 Lee chassis. Carrying a 30-ton riveted steel hull, this machine is pushed by a Wright Continental radial engine, producing 400 horsepower. Any working mechanic will immediately notice its extreme fuel burn. It can swallow up to 1 gallon of gasoline per mile, which is roughly 235 liters per 100 kilometers. That number forced logistics crews to design massive auxiliary fuel storage to keep the range usable. In return for its bulky profile, the 75mm gun mount integrated into the hull delivered fierce firepower, giving crews a hard-edged advantage against enemy armor. Step back to the late 19th century, and stationary power systems already showed sharp optimization. The 1881 Westinghouse boiler is a perfect example. Instead of the bulky horizontal boilers many firms favored, Westinghouse drew up a vertical boiler. The benefit was immediate: lower dry weight, less space wasted in the firebox area, and better mobility. It worked like a mobile power station, delivering stable, locked RPM through flat belts to drive threshing shafts on farms. Around the same time in Germany, Heinrich Lanz AG shaped the Lanz locomobile concept. This was a steam power unit mounted on iron wheels, built to supply pulling power for an entire agricultural workflow. The most valuable detail sits in plain view: a massive red-painted cast iron flywheel. It acts like a mechanical battery, absorbing shocks and smoothing torque when a saw table or a threshing machine suddenly bites into a heavy load. Watch the connecting rod drive back and forth and the steam pressure vent through the valve, and you can see the absolute precision of slide valve manufacturing.
Governor, come off, belt.
After the steam era, internal combustion took the throne. Look closely at the ignition ritual of the Lanz Bulldog tractor power unit. This one does not use an electric starter. The operator must use a gasoline blowtorch to heat the cast iron hot bulb on top of the cylinder head until it glows for about 15 minutes. When the heat is aggressive enough to prime ignition, the manual start begins. They remove the steering wheel from the steering shaft, insert it into the locking slot on the side of the flywheel, and throw their full strength into a hard swing to force the crankshaft past top dead center. This harsh start procedure demands the mechanic hold the timing angle and mixture ratio with a firm hand. Before we break down the specifications of the Soviet S-100 tracked tractor chassis and the Keystone skimmer bucket structure, if you are the kind of viewer who lives for core mechanical engineering and loves watching real teardown work, hit subscribe to The Engine History. Turn on notifications so you can follow rare footage where we strip, measure, and load test these heavy iron blocks. Your support is the budget that keeps the team measuring, tearing down, and putting these machines on the test bench. For sheer stubborn endurance, the DT-54 tracked tractor is a benchmark. Produced from 1949 to 1979, it tore through the harsh soil and rock ecosystems of Kazakhstan and Siberia. Engineers stripped away comfort and poured steel into reinforced load beams, pairing them with a slow-revving, hard-hitting diesel block. Its extreme load capability pushed it into export to 36 countries. Built on that lineage, the S-100 delivered massive winch pulling power for Soviet mining in the late 1950s. With an impact-resistant armored frame and wide tracks that bite into quarry ground, the S-100 specializes in continuous dozing under heavy load without overheating or failures. Even in the lighter weight class, designers drew brutal plans. The 1942 Harley-Davidson WLA had its entire top end reworked by mechanics. Engineers forced the V-twin's compression ratio down so it could swallow low-quality, contaminated frontline gasoline, prioritizing hard starting and stubborn reliability over high rev speed. On the German side, the BMW R75 used an extremely complex two-axle drive configuration. A drive shaft sends power to both the rear wheel and the sidecar wheel. It adds a differential lock, a reverse gear, and an auxiliary low-range gearbox, letting the chassis crawl through the worst mud imaginable. In the construction world, the 1926 Keystone skimmer shovel delivered an early mechanized earth-moving solution. Instead of a swinging arc bucket, this system uses a sliding bucket that travels horizontally along a T-shaped boom, built to scrape, strip, and control road grade with very tight tolerance. This cable and mechanical push-arm system eliminated manual grading steps and accelerated roadwork progress dramatically. Back in agricultural plowing machines, the Mogul 1020 from the 1910s used an open, exposed frame layout. By throwing away the honeycomb radiator, engineers cast a large volume water tank wrapped close to the combustion area to shed heat through evaporative cooling. Its enormous single piston squeezed the torque until the plowshare tore open hard soil layers. And the McCormick Deering 1530 is the machine that survived the toughest Nebraska test bench load standards, forcing rival manufacturers to lock in real, measured drawbar horsepower data. The most brutally practical design has to include the 1944 Zettelmeyer Road Roller. Cast from rough, heavy iron blocks, it carries no unnecessary parts. Static weight is driven straight into solid steel roller drums, compacting runway base layers and flattening muddy logistics routes. Its ultra-slow gearbox and stubborn engine block have only one mission: crush the surface into a load-bearing foundation. From 19th century steam systems to 1950s diesel combustion blocks, mechanical engineering has an unwritten rule. Cast thick, use the correct material, set lubrication clearances properly, and the load capacity becomes effectively limitless. These machines were born to plow, to haul, and to be wrung out across generations. Thank you for following this technical teardown and analysis on the engine history. From a working mechanic's point of view, do you rate the Lanz Bulldog heat start ritual higher or the tracked pulling power of the Holt 120 chassis? Leave your technical breakdown in the comments so everyone can compare notes. Goodbye, and see you again in the next mechanical teardown.